Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper published on May 5th, 2025, titled R1-Reward, Training Multimodal Reward Model Through Stable Reinforcement Learning. This research focuses on improving multimodal reward models, or MRMs. These MRMs are key for enhancing AI systems that work with multiple data types, like text and images, often called multimodal large language models. The paper explores using reinforcement learning, a technique where AI learns from feedback, much like trial and error, to boost these MRMs, but found current methods could be unstable. So they developed a new, more stable approach called StableReinforce. And for those looking to explore this further, the authors have made their code available. On GitHub, the R1-Reward repository has the R1-Reward model, the training dataset, and scripts for inference that's using the trained model to make predictions, and for training these multimodal reward models, including their StableReinforce algorithm. It's got what you need to get started. Okay, let's dive into the results. This first figure gives us a great visual of R1-Reward's performance across 3 different multimodal reward benchmarks. These are essentially standardized tests to see how well these models can judge multimodal content. The chart compares R1-Reward to several baseline models. What's really interesting is how R1-Reward's performance, shown in the blue, gray, and orange bars on the right for each benchmark, improves significantly when using a majority voting strategy. This means the model makes several attempts, like 5 or 15, and the most common output is chosen, which really boosts its accuracy. Alright, so we've seen R1-Reward's strong performance. This next figure really shows how their new StableReinforce algorithm, that's the blue line, behaves during training compared to an existing reinforcement learning algorithm, Reinforce++ in red. The left plot tracks policy loss. Well, that tells us how much the AI's strategy is changing as it learns. A smooth, low line indicates stable learning. StableReinforce achieves this, showing faster, more stable convergence. Reinforce++, however, becomes very unstable, spiking and collapsing around step 150. The right plot, for response length, or how long the AI's answers are, shows StableReinforce also helps the model produce shorter, more efficient responses. So, beyond those training dynamics, this next figure gives us a fascinating glimpse into how R1-Reward actually thinks. It's an example of what the paper calls a self-reflective thought process, or an aha moment. You can see the model working through a problem step by step, analyzing an image, calculating sums, and then, crucially, it actually catches its own mistake, stating something like, "My previous calculation seems flawed," and then recalculates. This ability to identify errors and correct its own reasoning mid-task is a really powerful demonstration of the more sophisticated processing enabled by StableReinforce. Alright, now this table 3, gives us a more detailed breakdown of performance on one of those specific tests, the VL Reward Bench. It compares R1-Reward against a whole range of other models, including well-known proprietary ones and other open-source alternatives. We're looking at scores for general understanding, how well the model avoids hallucination. That's when an AI might make things up, and its reasoning capabilities. R1-Reward, especially with that voting strategy we talked about, really shines here. It achieves an overall accuracy of 76.46% with voting, outperforming the previous best open-source models and even some proprietary systems on this particular benchmark, showing strong capabilities across the board. Alright, so we've seen that voting strategy helps. This figure 4 dives deeper into that, showing how R1-Reward's performance scales when it gets multiple chances to process the same input. These multiple chances are called inference samples, labeled quote, 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 along the bottom of each chart. Across those same 3 benchmarks we've been looking at, the red line, our majority vote strategy, shows accuracy improving gradually as quote, quote, increases, consistently staying above the previous state-of-the-art, which is the best result achieved before this research, represented by the flat green line. What's really striking is the teal line, the any correct strategy, meaning if any of the K attempts are right, it's a win. This any correct accuracy shoots up very fast, showing the model often gets it right within just a few tries, though the majority vote improvement tends to level off after about 5 samples. Okay, so this next table, Table 4, shifts our focus to a different test, the Multimodal Reward Bench. Again, we see R1-Reward compared with a lineup of other models, including proprietary and open source options. And the story is pretty similar. R1-Reward, especially when using that voting strategy with 15 samples, achieves the best performance across almost all dimensions, like correctness, preference, knowledge, and reasoning in math and coding. The paper notes it shows about a 14.3% improvement over the previous state-of-the-art on this benchmark, demonstrating really strong generalization, meaning it's good at many different kinds of tasks. Now let's turn to Table 5, which shows us how R1-Reward performs on yet another and reportedly more difficult benchmark called the MMRLH F-Reward Bench. Once again, it's up against various proprietary and open source models. And R1-Reward, particularly with that voting at 1.5 strategy, really stands out. It achieves an impressive 86.47% on a metric called ACC+, which seems to be a more comprehensive accuracy measure. This result significantly surpasses other models on this challenging test, again showing the strength of this new approach, especially with the voting strategy. Across these different and quite challenging benchmarks, it's clear that R1-Reward, especially with its voting mechanism, sets a new standard for multimodal reward models. This research really highlights how combining reinforcement learning with clever sampling strategies can lead to more accurate and reliable AI evaluation. It's a big step forward in building AI that better understands and responds to complex multimodal inputs. Well, that's all the time we have for today's AI Research Roundup. Thanks for tuning in, and I'm Alex.